Hey guys, Miss Davis here. If you're watching this, you should be on Unit 3, Skill 1, Solving a System with Inequalities. Okay, so a system is whenever you have two plus equations. Okay, so it's when you have two or more equations and you're solving them in a variety of ways for this one, so with inequalities. So essential question, how do we determine when a function is equal to, greater, or less than another function? So pause the video, write that down. Okay, all right, so example number 1, let's jump right in. It says given a graph. So there's a couple different types. They're going to give you a graph for some of them and sometimes they're not. So it says determine the values of x for when. So we want x values for when f of x is equal to g of x. So the best way to do these kind of problems is to grab highlighters. Yes, I'm talking to all of you. Grab two different highlighter colors and we're going to use them to interact with our notes and to visually see this so that when you look back at your notes, you can know exactly what we were talking about. Okay, so I'm going to highlight and make f of x green, and I'm going to make g of x yellow. Okay, so I'm going to highlight f of x in green, just to make this a little bit more visually pleasing on the eye. That was bad. So dip down, back up. Okay, and then yellow for the straight line. Okay, so let's label these as f of x was the green and g of x was the yellow. Okay, so the first one says where are they equal? Okay, so something to note that when they're equal, so equal to means, I gotta move this over. Okay, f of x equals to g of x means where do they intersect? Okay, so we look at this graph here, we can see that they intersect in two places. They intersect once down there, and they intersect once right there. Okay, so their intersection points, we only want the x values. So let's just write down what points they intersect at first. So this point right here on the bottom of the parabola is the point over 0, down 3. Okay, and then this point over here is the point over 2, up 1. We just want the x values though, because it says determine the values of x. So the two x values that we're going to have in our answer are positive 2 and 0. But when they ask you for the values of x, we want to write it in set notation with the smallest one first, so 0, comma, and our second x value where they intersect is 2. Okay? You could write them as x equals 0 and x equals 2. Would also be another okay answer. So x equals 0 and x equals 2 would be just fine as well. Okay, so for the next one it says, where is f of x, whoopsies, we want the highlighter there. We want when f of x is greater than g of x. So if you don't recognize that symbol or forgot what it means, this is greater than, okay? So greater than, so when f of x is greater than g of x, what they're asking for is where f of x is above g of x, and this is in terms of y, in terms of the y values. Okay, in terms of the y values. Okay, so we want to look at our graph and see where is the green above the yellow. So in other terms, green, we want green above yellow. Okay, so I'm going to look at the graph and, well, we don't want that moved. So where is green above yellow? Well, if you look right from here to here, this part right here of the graph, I don't know if you can see that, but this point right here, green is above the yellow, and from here to here, green is above the yellow. Right here, green is underneath the yellow because on going vertically, the yellow is on top of the green there. So we just want this interval and this interval as our answer. So how do we write that? Well, we want to write it that this interval right here, the first one is from negative, so parenthesis negative infinity, up to 0. So the x value of 0 is right down there. So it's from negative infinity, from the x direction, up to 0. And then parenthesis, not including that value. And then union, because there's another set that we have to put in there, from here up is at the x value of 2 to positive infinity. So now we're going to go ahead and write it union as positive 2 to positive infinity. Okay? All right, so the next one is saying where is f of x less than g of x? So off to the side, I interpreted that for you. So where is f of x less than g of x? That means where is f of x below g of x in terms of y? Okay? Or in other words, where is the green function below the yellow function? So if you look on the graph, it's green, or sorry, the green is below the yellow in the vertical way in terms of the y value is just right here. So from the x value of 0 to the x value of 2. So our interval that we can write it is from 0 to 2. Okay? All right, so moving on to example number 2. All right, so for the next example, we've got two different functions on our graph. So take your two different color highlighters, which you should have in your hands right now, and highlight this first function in yellow. So f of x, we're going to call this exponential function here and call it f of x. And then our green function, g of x, is what's called a hyperbola. So this hyperbola here is the green. It looks like a rotation of 180 degrees, but not around the origin, around this point here that's formed by these two asymptotes. Okay, so these asymptotes here act as like a wall. So this line right here is an asymptote. And it's at x equals 2, it's like a wall. And the hyperbola can never touch the wall, it just kind of rides along it until infinity. Okay? But it's kind of not really super important for this lesson, but it's just something to note. And going the other way too, there's another asymptote in there. So going that way. Okay? All right, so our first question is asking, where is f of x equal to g of x? It's where they intersect, so where does the yellow equals green? And we just want to make sure that we note that we're looking for the values of x, okay? So where do they intersect? I see one intersection point on this graph, and it is that point right there where yellow meets green, right about there. So what point is that at? It's at the point over 1, 2, 3, over 3, up 4. So the x value at which they meet is the point 3. Okay? All right, so for the next one is where is f of x greater than g of x, or where is the yellow function above the green in terms of the y direction? So the yellow is above the green right all the way from here to here, so from negative infinity. So we can label that here, like the end of it is negative infinity in the x direction up into the intersection point of, actually, it's only above it, right until it hits this asymptote at x equals 2 right here. Because as soon as it hits the asymptote, can you see how the green is coming in from this direction and is above the yellow as soon as it hits that asymptote of 2. So it's actually only above f of x, or g of x, from negative infinity up into 2. But then as you can see, it is above the green on the other side of this little bit here where the green is above the yellow. So now right at the point of 3, where they intersect back to positive infinity, is where the yellow is above the green again. So we're going to unite with the union symbol from 3 to positive infinity. Okay? And then the last one here is where is f of x less than g of x? So where is the yellow below the green? So the yellow is below the green for a very brief moment in time, right from here to here. So the green is on top of the yellow right from there to there, just between that asymptote of 2 to our intersection point of 3. So just from the value of 2 to 3. Okay? I just want to make note that we're not using brackets for these. Oh, sorry. We're not using brackets for these because of the fact that on these actual intersection points, they're neither greater than or less than, they're actually equal to. So they're kind of neutral. They're not greater than or equal to, or sorry, greater than or less than either function. So we use the parenthesis to show that it's right before that exact point. All right, flip over to the back side. So for the next example, they're asking you, or they give you two equations or a system of equations. Determine when h of x is less than j of x, rounded to the nearest tenth. But as you can tell, they just give you equations and there's no graph. So what I'm going to do now is insert a video, and we have to know how to sketch the graph. Okay, so sketch the graph using the equations and using some critical points and values. So I'm going to insert a video to show you how to do that on the calculator. All right, so we want to start by adding a graph to our calculate screen. And the first function, that h of x function from our notes, we want to do the absolute value sign, or those bars. So we hit the catalog button right there. And when you hit the catalog button, the very first one that pops up is ABS, that's absolute value. So inside the parentheses, we want to type in x minus 3, what's in our notes, and then plus 1 outside of the bars or outside of the parentheses. Hit enter, and that should show that little absolute value graph. Looks like a big check mark or a big V. So if I want to move this equation out of the way to kind of see the whole graph, I'm going to hold down the center of our little touchpad and drag it over here just to kind of move it out of the way. Okay, we want our second equation graph, so I'm going to hit tab. And then once we hit tab, we can type in our second equation, which is that j of x is the square root. So it's second x squared, or sorry, control x squared, absolute value of x plus 6. Okay, so we have our two equations graphed on there. And now what we want to do is find some critical values from our graph using these buttons on our calculator. So the very first thing we want to find are the intersection points, where the two graphs intersect or where they're equal to each other. So on this graph where the blue intersects the red. So the first thing you hit is menu. Go down to number 6 is analyze graph. And then down to number 4 is intersection. Okay, so intersection, you're going to have this little dotted line that's going to pop up. And what we want to do is move it towards our first intersection point. We have to do them separately. One set of steps for the first intersection point and then for the second. So right now it says lower bound right over there. So that means to the left of the intersection point, we want to just highlight it or put it right there and then hit enter. And then we want to drag it so that it's on the other side, the right-hand side of the intersection point, so that it's like a nice shaded region that covers the intersection point, and hit enter there. And once you hit enter, you'll see that it says the intersection point is 1.3, comma 2.7. So again, I'm going to move this out of the way by dragging it over here a little bit. Okay, and just dropping it. Okay, but we have a second intersection point over there, so we're going to do the same steps, menu, 6, 4. And this time I'm going to drag that dotted line to the left of the intersection point up here and hit enter. And then drag it to the right so that it hovers and creates that shaded region over the intersection point. Hit enter. And then there's our second intersection point, 5.37, comma 3.37. Okay, so our intersection points are two critical values, but our third critical value is going to be this bottom point, or the minimum point. Sometimes you'll have a maximum point if it was like a parabola or was facing the other way. So we're going to hit menu again. We're going to go to analyze graph, but this time number 2 is a minimum point. So we're going to hit number 2, and we have to choose which graph we want the minimum point of. So we want the minimum point of the blue graph. So I'm going to choose, and I just clicked on the blue graph, and now we have the same idea. We want to hit enter and drag the dotted line to the left of the minima, and then drag it to the right on the other side of the minima, and hit enter again. And then there's your minimum point, 3, 1. Okay, so that's how you find some critical values from a graph, and that should help you out with the rest of the notes. Okay, so now I'm going to pause the video and sketch what we just saw on that graphing calculator and labeling those critical values. So I'm going to pause the video, graph it, and sketch it, and you can copy it down. Okay, so there's the graph from our graphing calculator, nicely sketched. You want to make sure that you have the x and y axes labeled. You want to make sure that each of the functions that you graphed are labeled with their appropriate equations. And now I'm going to go ahead and highlight them in two different colors. So I'm going to do the green as the absolute value graph, and I'm going to do yellow as this exponential graph. Okay, so let's go back to our original question. It says determine where h of x is less than or equal to j of x. And something to note that if it says less than or equal to, then that means that if we're including the values in there, then it's going to be, we're going to be using brackets. So if it's less than or equal to, we're going to be using brackets instead of parentheses because we're including and are equal to the endpoints of the intervals. Okay, so we want to figure out where is the green below the yellow. So where is green below yellow? All right, so if we look on our graph, green is below yellow just right here in the y direction, so going up and down. The yellow is on top right about here and everywhere else in the graph. So before and after that intersection point, it's below the green. So the green is below yellow only from here to here. So we want to go from the x values from point A. See how I labeled them? Point A is this, oopsies, is this x value. And so from here to here, point B to that point value. So rounded to the nearest tenth, something to remember, this first point is going to be 1.3, comma, that second point is going to be 5.4 rounded to the nearest tenth. Okay, so in between these two values and including those endpoints, h of x is less than or equal to. So again, those are the x values. Okay. All right, our last example here is given two equations again, and I'm going to go ahead and pause the video and sketch what these look like and label some critical values for you. In a normal question, you would be doing these in your calculator, so why don't you also put these both into your calculator, so f1 of x, f2 of x, and try to get the sketch, okay? And then pause the video and then check your answers. Okay, so there's my sketch according to those two equations. And I've labeled the parabola with the x squared as the green graph, and then this linear function in yellow, the 1/4 x minus 3. So let's go back to the original question. Given the following system of equations, determine where t of x is less than, so it's not saying equal to, so then if it's less than with no equal to, then that means we're going to be using we're using just parentheses, okay? So we're not including the endpoints. So we want to find out where the t of x function, the green function, or the parabola, is less than the k of x, which is that linear function again. So looking at the graph, we want to determine where green is below yellow. Okay, so where's the green below the yellow? Well, if you look at your graph, starting from left to right here, the yellow is on top of the green, and this line actually extends out to negative infinity. So the green is below the yellow from negative infinity up to this point A, which we said right here, and the x value is the negative 2.77. And then from here to here, the green is above the yellow, so we don't want that. We want where the green again is below. So we're going to do this interval, so going from negative infinity up to this point right here, which x value is negative 2.77. And then we're going to unite from this point to positive infinity, going that way. Okay, and that point there at point B is the 2.52. Okay, so how we're going to write our final answer is from negative infinity up to the negative 2. Let's see, we went the nearest tenth, so negative 2.8. Union, and we have that little break, so we're going to unite with the other set from the x value of 2.52 all the way to positive infinity. Okay? All right, so there is your answer to where the green is below the yellow. And before you move on, really quick, I just wanted you to write down a couple things of what must your sketch look like in order to receive full credit. So a sketch is obviously not every point on the whole graph, but it's very important that you have a couple key things to get full credit on an exam or a test. So first, you want to definitely label your X and Y axes, so write these down. Second, you want to definitely put 3 points labeled on your diagram. So here we did our 2 intersection points and then the maximum point. So your intersection points, those are some critical values. Step 3, label your equations. This is very important. So label the end of each of the lines there with the correct equation that matches the function. And then step 4, always go back up to the original part, the original question, and answer it and round correctly. Okay, so go ahead and fill in your summary after you've done that and do all of your practice.